Three ways to represent or to show relationships. We've learned about relationships, so we'll do a little review here. Recall that there's a main topic of algebra. What is the main topic of algebra? Relationships. What are relationships made of? Pairs of numbers. And what is the big question? As one variable increases, what happens to the other one? And we're going to be talking about that a lot in what we're doing. Okay, so we're moving forward from the basic definitions to the three ways to show or represent a relationship. So we have different relationships. We had the amount of hours you work, the amount of money you make, the amount of miles you run, the amount of calories you burn. So what is a way to represent those? What are the three different ways to represent these relationships? The first way to represent relationships is a rule that determines, if I work this many hours, this is how much I'm going to make. What is the rule that determines that? A table is a good way to show various pairs of numbers. A graph really kind of shows us what is going on. Is it a more and more relationship, a more or less relationship? It just depends. So 3 ways to show a relationship. Showing relationships with rule, table, graph. And that's going to be a magic sentence, but I'll go over those at the end. We're first going to look at a table. And so a table, I have pizza, I make money. So there's my table. No, there's my table. So this is a table that can represent numerical relationships. Okay, so I'm making $4 an hour. Okay, so what would go there? That would be the hours. What would go in this column? That would be the money we make. Okay, and when we're in algebra, we're going to call that first one the x value. The second one is the y value. So when x is 0, so hours is 0, I make 0 money. When x is 2, so I work 2 hours, I make $8. 5 hours, I make $20. 12 hours, I would make $48. And so a table has various pairs of numbers that fit into this relationship of working $4 an hour. Okay, so the definition then of the table is that it gives examples of pairs of numbers. Gives examples of pairs of numbers. So here's the example: 0, 0, 2, 8, 5, 20, 12, 48. Just 4 examples of many. We didn't do 1, we didn't do 4, x equals 4. We didn't do all the numbers between 5 and 12. We just did 4 examples. And so a table gives examples of pairs of numbers. So what does a rule do? Well, rule, and we have pizza, we're making $4 an hour. A rule kind of talks about kind of the generic, is like, given any number of hours you've worked, how would I figure out what the money is? Okay, so the variables in this situation are hours and dollars. The big question is, as hours increase, what happens to the dollars? As hours increase, what happens to the dollars? And that is the big question. So the hours is what we'd call the independent variable. Okay, and so that's the x variable. The x variable is an independent variable. So it is the independent variable. The dollars is the dependent variable. How much money am I going to make? It depends on the number of hours I work. Dependent, independent. The x is the independent variable. The y is the dependent. If I know an x, I can find the y. Okay. So in this case, I'm trying to figure out how to get y. If it's dependent, how do I get that y? Oh, well, I can just simply, and if you kind of look at this, I just take the x value and do what? I take the x value and do what? I take the x value and do what? So what do I do to that x value to get that y value? Okay, so it's dependent on that. So to get from the x to the y value, I multiply by 4. That's the relationship there. That's the rule. Take the x value, multiply by 4. That gives you the y value. And that happens all the way down the table. So it's not if you go here, it's not, well, let's multiply 0 times 4. Okay, so I multiply by 4. Here, I multiply by 4. And then you're not going to come down here and multiply by 5, and then come down here and multiply by 7. It's always 4, every single row. If this is a relationship, this rule will work for all the pairs of numbers. So the rule is y equals 4x. So it builds pairs of numbers. Once you have that rule, you can build all sorts of pairs of numbers. The table gives us some examples. The rule builds any infinite number of examples. Well, what does the graph do then? So the graph takes those pairs of numbers and does a visual representation. The dependent variable is ours. Independent variable is ours, which is x. The dependent variable is money, which is y. Now, these little numbers in parentheses, these are indicating what the scale of that graph is. Okay, so it's counting by 10s here, and it's counting by 3s here. Okay, so 0, 0, boom. Now, what you might remember from last year is if it's 0, 0, it contains a point 0, 0. Not only is this a relationship, it's a special relationship called a proportional relationship. That's just further down the road here. 2, 8, 5, 20, 12, 48. And then if I used a rule to build more pairs of numbers, it would fill in all the spaces in between. And so we can use a line to connect those dots and say that every point on that line is a potential pair of numbers for this relationship. So 2 things about this, again, I'm going to point out 2 things about this. It does go through 0, 0, and it is a line. My line is horrible, but which makes this a proportional relationship. We're going to have a lot of linear is the word for line, a lot of linear relationships, but not all of them are going to start at 0, 0. So that's what makes this one special. We're going to start seeing some that start above or below that 0. So that's where we're going with this. That's what makes this different and unique from 7th grade and what we did in 7th grade. Okay, so a graph is a picture of pairs of numbers. A picture of pairs of numbers. So now you can see why we practice graphing those points. So showing relationships with pairs of numbers. The rule, y equals 4x. The table, which is a table, showing the independent variable on the x values, the dependent variable on the y, and a graph. The rule builds pairs of numbers. The table gives examples of pairs of numbers. The graph is a picture of pairs of numbers. Repetitive. So what does a rule do? Builds pairs of numbers. So these are the magic sentences. What does a table give? Examples of pairs of numbers. What does a graph give? A picture of pairs of numbers. What are 3 ways to show a relationship? A rule, a table, a graph. And so you'll see here, it's this picture, what does a graph give? And so it gives you different versions. 3 ways to show rule, table, graph. That's right. What does a table give? Examples of pairs of numbers. What does a rule do? Builds pairs of numbers. Okay, then we have some other stuff on today's work. So it's all integer stuff. So what you're going to need to remember is that multiply and divide, if it's same sign, the result is going to be positive. I'll say equals a positive. If it's different sign, it's going to equal a negative. And so you're just doing some examples of that. With add and subtract, it just different. So if you have different signs, you're going to subtract the numbers, and it's going to be the sign of the bigger one, which one had more. So in this case, we have different signs. So if positive 32 and negative 6, so we have to find the difference. So 32 minus 6 is 26. Which one had more? Oh, the positives. 32 was bigger, and it was positive, so it's more. So it's positive 26. If we have same sign, we're going to add the numbers, and it's going to be the sign they share. And I don't apparently have more examples of that, so we'll call that good. And then you notice from evaluating. So this is what we did the other day, so it's more practice of that. So we're saying x is negative 50, so it's plugging in here, but you already have a negative in front. And then in this, you're putting the negative 50 and then minus 50. So you have negative, and you put a negative into it, so it's going to make that positive. So 50 minus 50 is going to be 0. 300 minus 0 is going to be 300. So you're putting that 0 in for x, shoop, 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 just like that. Okay? And then evaluate. Plug in the number, perform the operations. We have the same one twice in a row. What are relationships made of? Pairs of numbers. The big question, as one variable increases, what happens to the other? Happens to the other one. What are relationships made of? So you're just going to have, the more times you do this, the better you should be at it. Okay, and then that's what your homework's going to look like.